Alright, derivatives of trig functions. In this video we're going to be talking about the derivatives of three trig functions. Okay, we're going to look at f of x equals sine of x, f of x equals cosine of x, and one more, f of x equals the tangent of x. Okay, so what are the derivatives of these going to look like? And I'll show you using GeoGebra. You're welcome to look up. There's lots of great activities on the web, on the internet about visualizing what's happening when we take the derivatives of these functions. Okay, so let's go on to a GeoGebra example here. All right, so this is investigating. This is going to show me the graph of the slope of the tangent line as I move from 0 all the way to different angles. Okay, so this red line indicates the slope of the tangent line, and it's going to plot this gradient for me. Okay, the value of m, it's going to plot as I move my x across. Okay, as I move this bar across, you'll see the graph change. Okay, so right now the slope of this tangent line, if you look closely, it says m equals 1. Okay, so the slope of this tangent line is 1. And what is this graph? Well, this graph is sine of x, isn't it? Okay, goes at pi, we have sine of pi is 0, sine of 2 pi is 0 as well. Okay, so now let's move this across. What's going to happen? As I move my x value, you'll see that my gradient is slowly changing. This value is slowly changing. It's tilting more and more so that it's going to become flat as I move across to this peak, right? So it's this dot, then you'd expect it to come back down here to 0. Okay? Because these dots are the graphs of are the dots on f prime of x. Okay? And we're going to look at the shape of these red dots and see if we can determine a function for that. Okay? All right, so I'm going to move my dot or my bar across. I'm moving my x values across. Now my slope is at 0.5, my m value. My slope is 0.26. As I hit 90 degrees, what do you notice? The slope is down to 0. Okay, so I have a bit of a curve forming right here. Let's see what happens as I move this across. As I move across, now my slope is negative. Okay, so because this line is pointing in a downward direction, my slope is a negative value, and you'd expect it to keep being negative. It would continue to be negative until I start going back up over here, right? Okay, so let's see what happens. You can see it's negative, negative. As soon as I hit pi, sine of pi is 0, and yet at this point, the slope has a value of -1. Okay? So you can see this shape forming. Can you guess what this is going to be? All right, let's see what happens. I'm moving it across, across, across. When I hit the bottom peak, my slope is 0. And because I have a horizontal line right here. Okay, and let's see what happens as I go up to 2 pi. At 2 pi, I come back to a slope of +1. Now, what shape do you notice about this? What shape can you sort of see? Okay, so you have to have some knowledge of functions in order to find this. Okay, let's keep going. You're going to see here it's repeating. Okay. So I'm going to let you pause this video, take a look at it. You can even try searching the internet on this. Just type in gradient function of trig functions and type in, here, I'll even show you the link right there. Okay, this is the link. You can pause this video and you can explore this yourself. Okay? Let's move on and see what the graph of, what the gradient function for the cosine function would be. Okay? So now here we have the cosine graph. This green function is the cosine graph, right? Okay, so maybe you can make some deductions about the previous derivative function based on this graph, but I'll show you anyway. All right, here we have the cosine function. Let's see what the derivative is going to look like. Right now it's 0, so my gradient is starting down here. As I go down this way, this line will become negatively pointing. Okay, well, the slope would become negative, right? Okay, and right at pi over 2, it starts to become less negative. It's becoming less negative, less negative, less negative. Right at pi, we see that the slope is back to 0. And as I keep moving, okay, the slope becomes more and more positive until I get to 3 pi over 2. And then the slope goes back down. Okay? So you can see here that there's a pattern forming. Okay, so this is the cosine graph. What kind of graph is this? This looks very, very similar to a graph that we've seen before. Alright, so you can pause this video and play around with this and make some kind of investigation using this site. Okay? Alright, let's go back to our lecture here. Okay, so what did you determine from that investigation? F prime of x looked like what? It looked like this shape, right? It started up here and looked like that. And this function, the derivative, looked something like this. Okay, and it just kept repeating, right? And this one kept repeating. Okay, obviously this would be consistent. Okay, well, we'll talk about the tangent in a little bit, but let's just focus on these two. So what graph does this look like, and what graph does this look like? Well, pause this video if you can see if you can get it. If you can't, then I guess just keep watching. Yes, that is right. F prime of x is cosine of x if f of x is sine of x. All right? If f of x is cosine of x, well, it's really just the sine function, but it's flipped vertically. Okay, it's flipped vertically, and that's why we have this negative in front of the sine function. So you do need to memorize these two. If I have a sine function, the derivative of that will be a cosine function. If I have a cosine function, the derivative of that would be a negative sine of x. All right. Now let's see if we can prove what the tangent function's derivative would be. All right. What is f prime of x when f of x is tangent? So we'll start with a proof, and you're just going to have to look at the bottom of the screen here because I don't want to give it away. Let y equals tangent of x. Let's rewrite this in terms of what we do know. Okay, I'm going to try to find y prime. Okay, so let's write this in terms of something that we do know so that we can find the derivative using our rules that we've learned. How about we write it in terms of sine and cosine? We know that the tangent of x is sine of x over the cosine of x. So let's substitute that. Okay, so I end up with this. Now, can I derive this? Well, it's really just u over v, isn't it? What's this? That's a quotient, so I can use the quotient rule. All right, so hopefully you can do this. Okay, let's see what the quotient rule looks like. There we go. Okay, this is the quotient rule, right? We have v squared on the bottom, v times u prime, or those can be switched, minus v prime u. So if u is sine of x, u prime would be cosine of x. So u prime is cosine of x, v stays the same, which is cosine, minus v prime. Okay, v is down here, so the prime of that, the derivative of cosine, is minus sine of x, so I put minus sine of x, times the original top function, which is sine of x. Okay, if I were to distribute these and distribute these, I would get cosine squared plus sine squared, right? There we go. What is cosine squared plus sine squared? Cosine squared plus sine squared, okay, of x is 1. That's a Pythagorean identity. You should know this from our trigonometry unit that we did. All right? So if I replace that, then I end up with 1 over cosine squared of x. And that is the derivative of the tangent of x. Okay? So if f of x is the tangent of x, f prime of x is 1 over cosine squared of x. Or if you are familiar with secants, okay, if you've ever heard of what, some of you may not have heard this before, but a secant is 1 over the cosine of x. Okay, so you can choose to memorize it this way or this way. They are the same thing. Okay, if you don't want to memorize it this way, just think about it like this. All right. So there you go. The tangent of x. If f of x is tangent of x, the derivative of that function is 1 over cosine squared of x or secant squared of x. Okay. Now the chain rule still applies to all of these functions. So how does our chain rule work? We have a function inside a function, right? So if I have sine of, instead of sine of x, if I have sine of f of x, what's going to happen? I would expect to see cosine of f of x times f prime of x, right? Same thing with cosine of f of x. If I have a mini function in here, well, then I have to do, to find the derivative, that would become negative sine of the original times the derivative of the inside. And so we end up with the chain rule being applied in this way. Okay, so if I have sine of f of x, this is what the derivative would look like. Notice these are all the primes of the inside function. Okay, everything else stays the same. All right, so let's do a couple examples here. Differentiate with respect to x. All right, so let's see. What does this look like and what does this look like? If I were to differentiate each of these, can you see a pattern here? Yes, everything that we've learned, we still apply. Our product rules, our quotient rules, our chain rules, derivatives of other functions like natural log, all of that will now be going into play when you do this assignment. Okay, so here we have two functions. Okay, we have basically a u and a v, so this would be the product rule. Okay, so if I were to do this with the product rule, then I would take u prime would be 1, if that's u, and v prime would be, what's the derivative of the sine? That would be the cosine of x. Okay, so the product rule says if I have the product of two functions being multiplied together, then I take u prime v plus v prime u. Okay, and so now I would just multiply 1 times x, sine of x, plus v prime cosine of x times u, which would be x, and that would be my derivative, sine of x plus cosine of x, or I guess you could put x in front here, x cosine of x. Okay, so that would be the derivative of this function. Let's try 4 tangent squared of 3x. Okay, so I have a 4, so that's going to remain the same when I take the derivative, right? 3x is my inside function. Okay, and I also have a tangent squared. Well, I haven't seen a tangent squared before, but what does that mean? If I see the tangent squared, that's going to be the same as, I can kind of pull this out and apply it so it's easier to see. Okay, so that's easier to see the power rule. Now I can use the power rule. Okay, so I guess I could say dy dx. Okay, let's say dy dx if this is y. All right, then dy dx is this, and now we can use our power rule. So I'm going to leave the constant out, and then I'm going to take the derivative of this part, and that would be 2 times the tangent of 3x to the power of 1, right? Okay, so it would be 2 times this function to the power of 1 times, I need to apply the chain rule here. So now I need to find the chain rule, and this becomes, what's the tangent of 3x? Well, that becomes the 1 over the cosine squared of 3x, but I'm not quite done because I have another derivative here, okay? This part right here is going to be the derivative of this function, of this inside part, right? Now, I guess I should probably move this parentheses out this way, just to show you how that's working. Okay, so this 2 comes in front, then I leave this inside part the same, raise that to the power of 1, because that's 2 minus 1, and then I take the derivative of the inside, which would be this big guy over here, so that would be 1 over the cosine squared of 3x, but I'm not done, okay, because to find the actual derivative of this, this also has to have the chain rule applied to it. Okay, so this would be times the derivative of this inside part, which is 3. So I'm really doing the chain rule twice here. Okay, and so this, now I'm done. There's nothing more to find derivatives of. I can't find the derivative of 3x, or 3x becomes 3, and that's as simple as it gets. Okay, so now I can simplify here. Okay, I have 4 times 2 times 3. Okay, so that would be 8 times 3, so that'd be 24. I would have times a tangent of 3x times 1 over cosine squared of 3x, so that would become a cosine squared of 3x. And now, since I have this in cosine, why not change this to sine over cosine and simplify it a little bit more? So this would become sine of 3x all over. This is really sine over cosine, right? Sine of 3x over cosine of 3x. Okay, so that would become, this part would go down into the denominator, and we'd end up with cosine cubed of 3x. Okay, you cannot cancel these. Please do not try to cancel these, because this is stuck to the trig function. Okay, these inside parts are being worked on by the sine. Okay, so this would be my final answer, and there you go. That's the derivative of this function up here. Okay, so hopefully you can remember. Please make sure you write these down in your notes, and also these green ones as well. These simple derivatives of trig functions. All right.